Hello people, welcome back to my channel, TheTalk. So today we are back with another video on polynomials. So in the last video we were discussing about how the division algorithm for the polynomials work. In today's video we will be discussing about the exercise questions that are dealing with the division algorithm of polynomials, that is exercise 2.3. And the first question says, divide the polynomial p of x by the polynomial g of x and find the coefficient and the remainder. It's nothing but the number which is being divided, and g of x is going to be the divisor. So let us verify the division first. So the dividend is going to be x cube minus 3x square plus 5x minus 3, and the divisor is x square minus 2. So we will recall all the steps that we discussed in the division algorithm while solving the question. So x square minus 2, the first thing that you have to consider is that highest terms of both the dividend and the divisor has to be equal. So this makes the equation's first term. So this is x square and this is x cube. So x square can become equal to x cube by multiplying it with x. So when it is multiplied with x, it becomes x cube, and x multiplied by 2 is minus 2x. So as there is no term with the power 2 or with power 2, so this is going to become 0 and minus 2x. So because it is division, so definitely we will consider the opposite signs, and this is going to become 7x, and you are left with the constant term, that is minus 3. Minus 3x square, and we have no x term, that is 0 plus 6. So considering the opposite signs, so it will become 7x minus 9. As the power of the new dividend is less than the power of the divisor, so you will stop your division here. So you will not consider further. This is another point that you have to remember when you are solving the division. So this will be the remainder, and x minus 3 is the quotient. So this is how we solve the first question. Now moving on to the second question. P of x, that is the dividend, is x power 4 minus 3x square plus 4x plus 5, and the divisor is x square minus x plus 1. So I have arranged it in the standard form while writing the numbers itself. So x square and x power 4 are the highest power. So to make it equal, we have to multiply it with x square. So the first term in the quotient is x square. So this becomes x power 4 minus x cube plus x square. So altering the signs, we get x cube. So minus 3x square. As there is no x cube term in the dividend, so you will be getting this as x cube itself. And minus 3x square minus x square is going to be minus 4x square. And you bring down the next term, that is 4x. So now it is x square and it has to become equal to x cube. So you multiply with x. So it's plus x. When you multiply, it's going to become x cube minus x square plus x. So altering the signs, we will be left with minus 3x square plus 3x plus 5. The only variation is that the constant term, so you have to multiply it with minus 3. So when it is multiplied with minus 3, we get minus 3x square plus 3x plus 3, and when you alter the signs, the remainder will be 8. So this is the remainder and this is the quotient. Next question. So the dividend x power 4 plus, let's make it 0x cube because there is no x cube term, plus 0x square, as there is no x square term, minus 5x plus 6, and the divisor. So if you consider it in the standard form, it will become minus x square plus 2. So you have to make them equal. This is minus x square and this is x power 4. To make it equal to it, you have to multiply it with minus x square. So when you multiply it with minus x square, this becomes x power 4, and there is no term, so it becomes 0 here as there is an x square term. So upon changing its signs now, so it becomes minus, it becomes plus here, so 0, and it becomes 2x square. You bring down the next, that is 5x. To make them equal, it is minus x square and it is 2x square. So only thing that is missing to make it equal to is you have to multiply it with minus 2. So it becomes minus. So x square multiplied by 2 is minus 2x square, and we even have another term, that is, we'll bring down the 6 also. So it will become 2x square minus 0x minus 4, because we are multiplying it with minus 2, right? It will become minus 4. So when you alter the signs, you will be left with a remainder of 10 and a quotient of minus x square minus 2. So this is how we use the division algorithm to verify the questions. And the next question says, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first. So what is the relation to tell if it is a factor? If it is a factor, the remainder is going to be 0. So that is the basic rule. So in this, the dividend, whatever is the dividend you are considering, is 2 power 4 plus 3t cube minus 2t square minus 9t minus 12, and the divisor is t square minus 3. The very first thing that we are supposed to do is we have to equate them. So t power 4, you have to multiply it with 2t square to make it equal to 2t power 4. This becomes 2t power 4. So there is no cube term, it becomes 0, and then minus 6t square. When you alter the signs, this is going to become 3t cube plus 4t square. You bring down the next term, minus 9t. So t square and 3t cube, they have to become equal to each other. So you multiply it with 3t to make it equal to 3t cube. So you will add 3t here. So 3t cube, so there is no t square term, 0, minus 9t. As the signs alter, you will be left with 4t square, and this will become 0 here, and you will bring down the next, that is minus 12. So the only thing to make it equal to 4t square is you just have to add the numerical quotient, multiply it with 4. So you will add 4 here. It becomes 4t square minus 12. So as signs alter, it becomes minus and plus here, and we are getting 0. As remainder is 0, so the dividend, that is this g of x, and if you consider the dividend as f of x, so g of x is a factor of f of x. So let's look at the next question. So we will take it as g of x and this as f of x. We know the relation that if it is a factor, the remainder is supposed to be 0. Now considering with the division, it is 3x power 4 plus 5x cube minus 7x square plus 2x plus 2 is the dividend, and the divisor is x square plus 3x plus 1. In order to equate them, we need like 3x square. So we multiply it with 3x square. We will be getting 3x power 4 plus 9x cube plus 3x square. As signs alter, minus, then minus 4x cube, this becomes 0 here, minus 10x square. You bring down the next term, that is 2x. Now it is minus 4x cube here, it is x square here. So you have to multiply it minus 4x. So minus 4x, now minus 4x cube minus 12x square minus 4x. So signs alter. We will be left with 2x square plus 6x, the last term plus 2, and it is 2x square and it is x square. So you will have to multiply it with 2. So add 2. It becomes 2x square plus 6x plus 2. Signs alter. You will be left with 0. So as remainder is 0, the g of x is factor of f of x. The next question in this exercise. So g of x, and this is f of x, factor if remainder becomes equal to 0. So considering the dividend, x power 5, there is no x power 4, let's write 0 x power 4 minus 4x cube plus x square plus 3x plus 1. So the divisor is x cube minus 3x plus 1. Now in order to make them equal, we have to multiply it with x square. So x square, then when you multiply it becomes x power 5, because there is no term, it is 0 here as well. So it becomes minus 3x cube plus x square. Signs alter. You will be left with minus x cube, and this will cancel out. So it will become 3x plus 1. Let's bring down the entire thing. So minus x cube here and x cube here. So you will have to multiply it with minus 1 to make it equal. So x square minus 1, it becomes minus x cube plus 3x minus 1. So when signs alter, so we will be left with the remainder of 2. As remainder is not equal to 0, g of x is not a factor of f of x. So this is verified by using the division algorithm. So I hope you have understood how to solve the questions using division algorithm for polynomials. So we will be continuing the next exercise questions in the next video. So please do subscribe to our channel, The Talk. So see you in the next video with another topic. Bye-bye.